Welcome to the Internet Report, where we uncover what's working and what's breaking on the internet and why. So we've had a few weeks off. You may have noticed that we missed a few episodes, but we're back, and we have a really interesting outage to cover this week. So we're going to be talking for the full episode today about the Facebook outage that happened last week. So that was April 8th, Thursday. And the outage started at 21:30 UTC, which is 5:30 Eastern time or 2:30 Pacific time. So really kind of in the middle of the day, late afternoon in the US, when I'm sure they have a lot of users using the service. And then it didn't fully resolve, at least from the application standpoint, until 22:10. So it was about 40 minutes that people kind of were complaining that they were unable to use Facebook. Now,
Angelique, I'm going to call out that application standpoint, which you had, and stress a little bit on that, right? So there's a reason we're specifying why, from an application standpoint, the outage seemed to have lasted for about 40 minutes. But really, from a user experience point of view, we did notice the effect to be more prolonged, and that's kind of what we'll be uncovering in today's episode.
Yeah, so what most people were noticing and complaining about was really just kind of phase one from what we were able to see. And so we're gonna talk about phase one, which of course everybody noticed. It was pretty obvious, but we're also going to cover the other two phases that would have also impacted users around the world, and kind of how that manifested and what potentially was causing some of these issues. So pretty interesting stuff. So with that, we're going to go ahead and dive in and take a look at what we saw.
Point we were making is at 21:30 at 5:30 Eastern, we did start seeing the impact here. We are monitoring globally, as you can see, to facebook.com. And then again, 40 minutes in, things look good, as in it took 40 minutes from an application standpoint, connecting to the HTTP server here, starting to look better. But then let's kind of, narrow this in and start stepping through this, through these different phases, because there's a lot of things happening here. So starting at phase one, right, which is purely from an application standpoint. Some of the things that's really obvious here is that it is a global event. Everybody across the globe was unanimously impacted because of this.
Yeah, and it manifested really at the application layer in terms of these server errors. So we were seeing principally 500 errors, which is indicating there's, it's a fairly generic error code, but kind of indicating there's something within the application that's not able to fulfill the requests. And then we're also seeing a 429, which is more specific and basically saying that, it's not able to handle it because it's just simply getting too many requests. Right. So that was pretty interesting, and really kind of spoke to, the availability of the application itself. So that was, pretty extreme kind of state of performance where you're just not even able to use the application.
Right. And as it started recovering, like from an application perspective, which was 15 minutes in, we're starting to see some type of mitigation effort going in place there, right? We're starting to see some regions come back up while the others are still, having issues. But this trend was not, progressively getting better, in the sense that, in this time frame where it looks like the Americas are recovering, the next time frame, it actually has gone back down to red, which means server availability was still questionable at this point in time. This is kind of the pattern that we saw throughout, the 40 minutes, and finally where it started recovering.
Yeah, and you will, if you're noticing the different phases there, you'll notice that some of the errors then start to shift away from being purely HTTP, server related, and some of them are even, in the connect phase and the receive phase. So indicating that there's potentially a problem happening at the network layer as well. When we talk about kind of these mitigation efforts, which we'll dig into a little bit more. But this basically, as we were starting to see the recovery, so availability started to increase. We see this pretty dramatic spike in network loss, so packet loss, as well as network latency. So if we kind of flip the metric there, we'll also see that there is also kind of this increase in latency.
Right. And just like, pulling the timeline a little back so you can see the relative, increase in here from a latency perspective. Now, this is the period where, it was purely just an application issue as it was manifesting. That's what we are calling phase 1, right? And phase 2 is when we're starting to see this impact in the network layer itself, manifesting as packet loss as well as increased latency in here. I think at this point, I'm going to flip over to path visualization, because this increase in latency kind of, I think before we double click into why that is happening, I think it might be valuable to just talk about how Facebook does its routing in general. So I'm just going to pull this up.
Maybe if you just go back, also one more interval when it was normal. So before the loss and latency spiked. Because it's pretty interesting. So there's different ways in which application providers can route users to their service, regardless of whether they're a highly distributed application or not. So you could do things like, for example, Anycast, where you're advertising, the same, or few IP addresses, and you're basically leveraging BGP to hopefully get users, because BGP is basically going to send users down the shortest path, and hopefully that will give them the best experience and route them to the optimal server. That's not what Facebook is doing here. So the way that Facebook routes users to its services through DNS load balancing. So you can see that there's almost a one-to-one mapping between applications and the servers that they're connecting to, and they're really connecting to servers that are very close by to them, right? So they're using kind of the client subnet to determine which IP address to serve them, which would then route them to the ideal server.
It's really like it's serving the point of what a CDN would, getting you to the closest edge location as possible. And this is, I really like this view as we're flipping through it, because it kind of shows you that 1:1 mapping, right? Depending on where the users are. Mexico, Houston connecting to Dallas, Ashburn going to Boston, and then Barcelona connecting into Madrid here. So I think this is a nice way to see where exactly the edge servers are, and also a good way to understand if it's optimal routing or not.
Right, and you can see, so this is kind of the normal state, before we started to see this increase in loss and latency. And so, what you'll notice is that there is, in fact, a difference in terms of how users are getting, which server they're getting connected to. So what we noticed was that there are a lot of locations that started to get connected to a particular IP address that we see here. So this is, a /24 prefix, and you can see, the IP address there, the prefix there. And this was, this is an unusual prefix for Facebook, because it's really just advertised through one transit provider, rather than a diverse set of ISPs and transit providers. And so when they did that and started sending users to that particular IP address, it seemed like, for whatever reason, whether it was intentional or not, or maybe there was too much traffic that was getting directed to that through that one transit provider, that we were seeing an increase in latency and loss.
And I think one thing to call out in terms of, you're mentioning Anycast before, that Anycast works in the way that the IP address still remains the same, but you're getting connected to your closest server. And that's not what's happening here. This is not, an Anycast based routing that Facebook's following in the mitigation phase. These particular locations are actually being directed to the static server here. And just looking at Houston relative to all the other, locations we're monitoring from, you can see how quickly, basically latency when Houston was previously connecting to Dallas, it was around 4 milliseconds, but now in that phase 2 piece where we are seeing all of that packet loss, it spikes up to some cases, as high as 82 milliseconds as well. So it's definitely, not very optimal at all from a location perspective.
Right. So, I mean, it looks like, this brief spike, right? It then did start to, it just kind of really almost fell off a cliff. And, what you see there from a network path standpoint is that those locations are no longer going to that particular IP address, which was like a 157, 240 dot,
it was a 206.0/24.
Yeah, slash 24. So here they're going to an entirely different server, except these ones are located in Europe. So we can see that Mexico's connecting to a server in Frankfurt and Houston's connecting to a server in Vienna. Obviously not an optimal way of routing users, but it did seem to at least address the issue of this packet loss that those locations were experiencing and the outsides latency. Now, simply from the standpoint of what we're looking at here, I mean, this is a very simple kind of TCP handshake. So you do see that red portion there, that's that increase in latency. That's probably, it going over the Atlantic, and so it just by virtue of it being further away, there's, it's a little bit further, but it's not really extreme.
Yeah, it's not. And we're filtering here and looking at it from just a couple of locations. Now we saw this across a variety of, nodes as well. Ashburn, for instance, was being pushed all the way instead of Boston to Barcelona. And this is kind of, leading into this phase 3 that we were talking about, like the stage 3 that we're looking at, right? Like, so stage 1 is when the app was, errors were manifesting. Stage 2 was when the spike in packet loss was, but almost like when packet loss falls off a cliff, you expect, things are better, but in a way it's not, because you're not connecting to the most optimal location as well.
Yeah. What's interesting is if you start to step through the timeline, you can kind of see that there was all kinds of like movement in terms of which server these two locations were connecting to.
Like just focus on the path and the end node that you're seeing as to where that location is in here that you're looking at, right? Like just going to do kind of a quick fast forward of sorts. Let's see. Oh wow, it goes to Frankfurt, Copenhagen. Let's just filter based on only on Houston, just to simplify this just a little bit more. There you go. Right. Okay, it goes to London and then it finally comes back to the US. So this is at 23:15.
Yeah, so it's kind of bouncing around different locations in Europe, and then it doesn't get routed back to a server even in the US until 22:15. So at least then you're seeing that whereas that kind of that slight elevation in latency then kind of went down to almost kind of pre-incident levels, and then eventually I think it's like a little bit further down the timeline,
it comes back to its resting state of sorts.
It gets closer, and then eventually it's back to Dallas, which is what it was before the incident. So, I mean, it didn't kind of normalize for a while. So clearly there was something happening in terms of Facebook effectively doing some shuffling of users across its edge infrastructure for whatever reason, in order, maybe they were, there were issues and they were connecting them to the servers that they knew to be available and able to handle queries. It's kind of clear.
Yeah, I especially given the errors that we were seeing initially, right? We were seeing like, 429, for instance, on the HTTP side of things. Almost feels like they were trying to do some kind of load shedding and move their users across, spread them around. So while it did look like the outage was resolved in about 40 minutes, the experience was not necessarily up to, to an optimized state. And I think that's what gets more obvious again if we jump back to.
Actually, if you jump to the to maybe in the timeline where there's an increase in
the packet loss, right?
Not necessarily packet loss, even when just after the packet loss occurred, right? If you go to network latency just for a moment, you see there that latency is, it's slightly elevated, right? Like it didn't, yes, there was a drop off in loss and latency, but now the users are getting routed to Europe. And so there's a slight elevation. So what you can kind of say is like, okay, so maybe, it's like 100, milliseconds network time, 100-ish milliseconds. Maybe that's not extreme from a network standpoint. We don't see this massive spike, but the influence on the page load time, tells a different story. So if we kind of move up into the page load, tab, we can kind of see.
I'm just going to pull this back. So there's a relative view of the entire thing. Yep.
In this case, it timed out. And then here we just see that, it's taking a lot longer to load the page than normal, right?
And the place it timed out is the place which is stage 2, where there was
kind of transitioning, right? Like in that period. So, but now it's just like it's going to a server that's further away, and just by virtue of the fact that you need to connect to the server, you need to then request the components of the page, and then those components need to be served to you. And again, all of this takes network time that just adds up. And
and I think in this particular case, like, the components that we're loading were more static because we were just connecting to facebook.com. But if it wasn't the case where you did have to do a backend fetch, for instance, to the origin, then just moving away, moving that front door further and further away is just going to add up, especially if you have any backend interactions that's happening.
Yeah, this was a really, really simple page. And so, and the components were all hosted within Facebook servers, right?
Yes,
so we don't
exactly.
That's very atypical of most applications. You would typically see not only that you're going to make queries on the back end to maybe fetch the index, file or other components, but you're also going to have like other third-party services that that you need to fetch in order to load the page. It could be like Google Analytics, it could be, other things, and you don't see that here. So, we see a spike in page load, but if it had been a much richer, kind of more typical application or front page, it probably would have been a lot worse than what we see here.
It would probably even timed out, and it would have manifested as a timeout here, just taking that long, right?
Yeah, potentially. So, so this was kind of interesting because, to your point, there's a lot of press around the fact that the application was unavailable, and that's fine. That's pretty extreme performance situation, but, there was lingering issues in terms of how it was impacting users. And unless you have kind of like really granular insight into things like, okay, well, how are they really routing traffic, and what's actually happening underneath the hood that's influencing, what users might be experiencing. So, this was a pretty unusual event from the standpoint that it had kind of these very different characteristics. And most of them went kind of unnoticed, it looks like.
It did. And I think this again brings that discussion around availability versus performance, right? Okay, you're testing if something is available, that's great. That's kind of the first step. But that doesn't just because it's available doesn't mean it's performing at its best. And I think that's what this particular incident really calls out, is being able to like not just test for availability of a server, for instance, but being able to go that one step further and seeing all those changes. The other thing, I'd also add is sometimes the usability of the application. In this particular case, we're just really like getting to the front door of facebook.com, but to truly understand if the application is performing is to know if the application can be used by the users in a true fashion, which is say logging into Facebook, like, scrolling through a page or whatever that might look like, or the wall, or, whatever that's called these days. And I think that's more important to truly understand performance of applications rather than just, availability and, HTTP response times, right?
Yeah, and just kind of part of that, just to add to that, so, very kind of traditional metrics that, for example, maybe just the network team would be looking at things like, okay, well, what is my network latency and what is like my loss or jitter or whatever, and these other kind of key performance indicators. Well, at the end of the day, what really matters is the usability of the application, not just availability, to your point. And so, while the network metrics may tell a story, they don't really mean much unless you can correlate them with how a user is experiencing the application. So it's really important to kind of not get too, like fixated on certain metrics in isolation, because it's really at the end of the day about how the network latency and the network loss, if it's there, is impacting.
It's impacting. It also is, if I think about it, like understanding that correlation to the application also gives like classic network teams, some way of identifying priority, right? How do you prioritize an incident? Say you have like 2 network related incidents happening, but which one's actually impacting the user? Because that's probably going to be higher in the queue. So it also gives you a way internally within, teams to prioritize and move forward operationally, right? So just that correlation and contextualization across different layers of the stack. So if we call it that way, I think becomes really important.
Yeah, for sure. And even on that, like just knowing, for example, okay, I have elevated latency or elevated loss, okay, and that's related to how the application is performing. That's great. And that's good to be able to correlate that, but also understanding like what's contributing to the latency. So in this case, we can see that there's actually a routing issue, right? And so it's like, it's nothing happening within, say, an ISP that maybe like, moving traffic around in their network. It's actually the application provider and the way that they're advertising and driving users to their services. That's the problem. So it's not the application itself that's the problem, but it's still the application provider that's the problem. Being able to identify who is actually causing the latency is really important, versus like, hey, if it's network related, it's got to be like, maybe it's probably my ISP or something else is going on. So that attribution of the problem is really
important. Yeah, as you were talking about it, another angle I see that is if you are like, in this particular case, Facebook was, influencing those changes. But if you own an application and you are the service provider itself, if that's the service you're providing, and say, something similar happens and you're trying these mitigation tactics, right? But just to be able to monitor that in correlation with, okay, I'm doing this change. Is it really impacting, I'm up and running, but is it really impacting users? And being able to step through that is a nice visual and kind of fact check as well if the mitigation's going as planned.
Yeah, absolutely. In particular, if you're using like Anycast and you're kind of trying to figure out if your changes, like made any changes and what the outcome is, because that can be really finicky too. So yeah,
definitely. It turned out to be a good comeback episode though.
Yeah, definitely. We got to hit all kinds of things, like from internet routing to application performance. So a nice illustration point on just kind of how all of these different things matter, right?
Right. Yeah. All right, so that's our show. Don't forget to hit subscribe, follow us on Twitter. If you have questions, feedback, or guests you'd like to see featured on the show, definitely let us know. Email us at internetreport@thousandeyes.com. And if you are new to the show and you haven't yet claimed our free t-shirt, feel free to do so. Just send us your address, t-shirt size, and we'll get that right over to you. With that, we'll close today's episode. Thanks, guys.